All right, here we are with our next video on operations and functions, multiplication, division, but this time we're going to be looking at with just variables, simplifying expressions with those variables. So let's do a small review before we get into our content today. So some things you're going to have to know here is just a review of what we do with exponents, how do we combine like terms, and what are like terms. So our first example here, we have x squared times x. Now, a lot of people want to add these together and say, well, we've got 2x squared then. What we need to remember is that we actually can rewrite this, and this could be written as x times x for our x squared, and then times x for that other x. So we're really multiplying three x's together, which is x to the power of 3. And this is what we would do when we're multiplying variables that are the same. So x squared times x is x to the power of 3. Take a look at this one.
That's the power of 3.
So unlike this one here, this one says 3x plus x. Well, that
so you had 3 girlfriends that's your x, and now you have another girlfriend that's your x. So how many x's do you have?
In this case, we have 4 x's.
That's a lot of x's.
This is not multiplying. This is adding or combining like terms here. Our next example, we have x plus x. And like Mr. Craig just said, if you had an x and then you had another x, you've had 2 x's.
2 x's. Snap.
Right?
They live in Texas.
Oh, gosh. All right, here we have x squared plus x. Notice it's asking us to combine these through addition. However, they are not like terms. X squared.
But they're both x's.
X, they are not like terms because here we are multiplying 2 x's together, and here we just have a lone x. So x squared and x are not like terms because they do not have the same exponent. If, for instance, this were x squared plus x squared, now they're like terms, and we could combine them to say we have 2 of those x squareds. So it's not what we have, though. So let's go ahead and do it. This is actually already simplified because we can't combine those 2 terms.
Okay.
Here we have x squared times x to the power of 3, or x cubed. X squared times x to the power of 3, though, is not asking us to combine. So they don't need to be like terms to multiply it, but because they are the same variable, we can multiply them. And just like we looked at down here, this one can be rewritten like this. X squared can be written as x times x. And then
I got this one. The next one's going to be x times x times x. So together they're x times x times x times x times x.
Yes.
How many x's is that?
How many x's is that?
A lot of x's.
That's 5 of them. So x to the power of 5 is how we can rewrite this one. So, and really what we have here is a property of exponents that we learned a while back is when you're multiplying the same variables, all you have to do to the exponents is add them. 2 plus 3 is 5. So x to the power of 5.
If the bases are the same, yep, that sounds cool.
Our last one here for our review is 3x squared plus x times x. Now we do have to look at our order of operations here. We want to take care of our multiplication before we take care of our addition. X squared would be an exponent that we can't solve, so we're just going to leave that as x squared. And then 3 times x squared, we can't do anything there either. So that term we're going to leave alone for right now. And then right here, we have x times x. And just like we reviewed earlier, x times x, those are both to the power of 1. And because we're multiplying the same variable, we could add the exponents to get x to the power of 2. So I'm just going to drop all this down. 3x squared plus, and then x times x is x squared. And now we have like terms. We have an x squared here and an x squared here. We have 3 of them. And then the creepy coefficient here, the one of them, if I have 3x squareds and another 1x squared, how many do we have, Mr. Craig?
You got a whole lot of x. Oh, sorry. You got 4x squared.
That's right. And so that's kind of review of exponents, combining like terms, and multiplying variables.
That's a great review, Mr. Nelson. I think I'm ready for the lesson now.
Well, that's good, because that's where we're going.
Yay.
So our first example here is we're going over some multiplication. It's asking us to simplify f times g of x and it gives us what those functions are. F of x is 2x plus 5, and g of x is x to the power of 2, or x squared. And so just like we've already done before, we are going to be substituting f of x and g of x, but we just don't have a number to substitute in for x this time. So what we would do is write parentheses around our f of x, and then parentheses around g of x, and then substitute out with those functions. We end up with something like this. In parentheses, 2x plus 5, and then because we're multiplying, we put the multiplying symbol, and then we have x squared for g of x in parentheses because we're substituting.
That looks hard.
Yeah, well, it's multiplying, and just like before, if we have something with two terms, if we have a parentheses with two terms and parentheses with one term, we could distribute. So let me kind of go on a tangent here.
Well, could you show me a way that's like visual? Because I'm really lost.
Yeah, so there is distribution that we could do here because distribution is multiplication. And so we can distribute backwards here. Another way to look at this is through that table method that we showed you earlier this year.
Ooh, the area model.
The area model. So I could take the first function here and write it up here and say 2x plus 5. And then take my second function here, which is x squared, write it here. And what that leaves us with is, I'll break these up by term. Let's see here.
What's a term?
Terms are broken up by addition and subtraction. So every time that I see an addition or subtraction symbol up here on this top, 2x plus 5, this function, I'm going to write a line. So that means that I should, after I multiply through, we should have two terms left.
Got it. Thanks.
So, you're welcome, Mr. Craig.
I'm learning a lot today.
And because we got to remember that we are multiplying, and so what we're going to do here is we're going to take x squared and multiply it by 2x. So x squared times 2x. And what I'm going to do first is multiply my coefficients. My coefficient.
Where's the coefficient?
That's the creepy coefficient. The coefficient's
oh,
1.
Yeah. Yep,
1 times 2 is 2. And then I'm going to multiply my variables. X squared times x. And like we went over in the review, this is x to the power of 1. Because we're multiplying those variables, x squared times x to the power of 1, we just add the exponents. So x to the power of 3, that's right. So x squared times 2x is 2x to the power of 3. And that's for the first multiplication. It would be like distributing here. And the next one is going to be x squared times 5. I'll go ahead and write that down here just to show you, but x squared times 5. Don't mind my crazy 2 there. X squared times 5, again, multiply those coefficients, if you will. 1 times 5 is 5. And x squared, there's nothing to multiply it by, so we're just going to, it's not 0, it's just x squared. So 5x squared is what we have here. And it should be positive, so we're going to go ahead and put plus here. And now we have our multiplication complete. I'm going to rewrite that real quick. Remember that. Can
you also show me how to write that into Canvas? Because that looks very confusing.
Yeah. So what we have here is we want to make sure that if it comes down to it, you might have to combine like terms here. These two terms here, 2x to the power of 3 and 5x squared, are not like terms because they have different exponents. So let's go ahead and write down what we have here. We have f times g of x equals, right here we have 2x to the power of 3 and then plus 5x squared. And if you were to write this in Canvas, this part will be taken care of for you. The way you'd write this in Canvas would be 2x to the power of, you're going to do the caret 3 plus 5x and then the caret 2. And that'd be how you take care of that in Canvas. Any questions or anything you'd like to add?
Well, Mr. Nelson, before you were showing us a cool way to type it into Google. Can't you do that on these ones?
No, because Google does not know what the value of x is, and it doesn't know what terms are if they have an x in them. So this does have to be done by hand. It won't combine like terms for you.
How do I write it? Oh, I see it. Okay, I got it. I can see it. I see it. Okay.
So anytime it's of x, then I can't use Google only if it's a number, then I can use Google?
Yeah, so if you had a value given to you for x, for instance, if this asked you f times g of, I don't know, a number there for x like 2, then you could type, because you're going to replace all the x's with that value, and then you can type that into Google.
That's deep.
Deep.
Show me one more. Show me one more.
All right, let's move on to our next example. This one's not multiplication. This one is division. It says that f of x is 2x plus 5, and that g of x is x squared. And it's asking for division here. So what we're going to do is write it as f of x divided by g of x, and then we're going to be replacing those with what they are. F of x is going to be replaced with 2x plus 5, and g of x will be replaced with x squared. And this is what we end up with.
With the parentheses.
Yeah, we also use parentheses there because we want to make sure that we're keeping everything grouped together. And a lot of people ask me here, well, what do we do now? That's it. You know what f of x is going to replace? 2x plus 5, and then divided by x squared.
How come?
Well, because there's nothing left to simplify. There is a way to simplify this, but it actually just doesn't look as simple. There's nothing here to simplify. We can't take 2x plus 5 and divide by x squared and get anything from it. So this is actually...
So it's just easier to leave it alone.
Yep,
okay.
Just easier to leave it alone.
Show me how to type that into Canvas then, because I don't want to get it wrong.
Yeah, so we're going to type this into Canvas. We're going to start with the numerator, in parentheses, 2x plus 5. We are going to use a / for our divider sign, and then we are going to divide by x squared, which I'm also going to put in parentheses. But to the power of, we're going to use the caret sign, 2, and then a last parentheses.
That's cool.
Anything to add there?
Nope, I think that's pretty cool. You know, I don't have to, though, put the parentheses in the final answer on the bottom, right? Because it's one term?
Yeah, because that's one term down here, you don't. It's just best to do that.
Smart.
Good practice. If you do it, you'll never get it wrong, but if you don't do it, you could get it wrong. So
cool. We have 2 more examples, people, but if you get it from here, you go ahead and try the activity, but we got 2 more just in case you guys are struggling.
Yeah. All right, so here we have f of x is 4x plus 8, and g of x is equal to 2x. And then we have f times g of x. This is multiplying. So I'm going to go ahead and set up my parentheses first. I'm going to go with red, stay color-coded here for a little bit. The first function is f, so I'm going to go ahead and write this in parentheses. So f of x. Let me just write that out actually first. Let's do this. This is going to be f of x times g of x. That way we can kind of follow along here. And then now I'm going to start replacing and substituting out my functions. F of x first. So f of x is 4x plus 8. And that's going to be multiplied or times by g of x, which is here in blue. And g of x is 2x. Now, some of you guys might be wondering why I'm not replacing the x with parentheses. It's because I don't have a value for x. It's not given to me here. And from here on out, again, it's multiplying, so I would highly recommend that you just get used to the table model for distributing this 2x into 4x plus 8. So I'm going to start by writing 4x plus 8 as my first function here. And then 2x on the side. And then draw in my table. You notice I have a plus sign here, so I'm going to be drawing a box. And there's 1 plus, because I have 2 terms there, there should be 2 boxes. And so in the end, I have 2x times 4x plus 8, and we're just going to multiply it into those boxes. Let's use green here. Hey, is that green?
That's green.
It looks exactly the same as red. So first thing I'm going to do is take 2x and multiply it by 4x. Just to kind of break that down again, 2x times 4x. I'm going to multiply my coefficients first. 2 times 4 is 8. And x times x is x to the power of
2.
2. So that's
2
8 squared. And the next thing I'm going to do, even change this color up, 2x times 8 now. 2x times 8, probably already know this, but 2 times 8 is 16, and then x there. And that's going to be positive because it's a positive 2x times a positive 8, and so that's going to be plus 16x. And then we're going to check for like terms, combine them at this point. I'm also going to bring down the f times g of x.
Because that's the relationship.
It's the relationship, that this part up here. And then I'm going to write this down as 8x squared, then plus the 16x right here. And those
And
are
how
not,
would I put that in the calculator?
well,
I mean,
you
in
can't
the
put this into a
computer?
calculator. You can't put this into a calculator because it has variables. However, to type this into Canvas, you type in 8x to the power of, which is the caret key, 2, plus 16x.
That seems easy.
Anything to add to that?
I think that's awesome. Let's try that last one.
All right. We have another division problem here. It's using the same functions, 4x plus 8 and 2x. But this time we are dividing. All right, so that's actually usually the first thing I will actually write is my division symbol. I like to write them vertically when I'm taking notes. However, when we type it into Canvas, we can't write it vertically like this. Let's start with f of x, since that seems to be the numerator. Let's write f of x, and I'm going to write that in parentheses. Let me actually just write this out first. We have f of x divided by g of x. Whenever I replace something or substitute it, it's a good idea to use parentheses. So these will be added on the second part here. So f of x first. F of x in parentheses. And f of x is 4x plus 8. All divided by g of x. And g of x is 2x. And there we go. A lot of you guys might think this is simplified, but you'll notice something very interesting about all of the coefficients and the constants in here.
I know.
What's that, Mr. Craig?
They're all divisible by a number 2.
That's correct. So although we will accept this as an answer right here, this could be simplified. Everything is divisible by 2. So take each and every one of these numbers, 4, the 8, and the 2, and divide everything by 2. You could do that. And you could say, well, 4x divided by 2 is 2x. 8 divided by 2 is a positive 4. And 2x divided by 2 is x. So this is also another way that could be written. However, we are perfectly fine with this answer here.
Okay.
One more thing, just to learn how to type this into Canvas. If you wanted to type this into Canvas, remember, put your numerator in parentheses, and then a / for dividing, and then your denominator in parentheses as well.
So if you have more than one term on the numerator or the denominator, you should put it in parentheses.
Absolutely. So in this case, we wouldn't technically have to put the denominator in parentheses because that is one term. Just safe to.
Cool.
Anything else to add?
I think that's awesome. Get to work, people. Get to work.
Yeah. Remember to inbox us if you have any questions.